Welcome to lesson 8.5, Areas of Quadrilaterals. So just like how we looked at the area of triangles can be deduced from that idea that an area of a rectangle is length times width, now you'll see that the quadrilaterals that we're looking at today, which are not rectangles, those area formulas are deduced or come from that idea of the area of a triangle formula being 1/2 of base times height. So as we go through today, you'll see the idea that some of these triangles tend to be shown by being created using altitudes or heights in the images. So the first thing we're looking at is a trapezoid. So again, the important thing to understand in a trapezoid is anytime we say base, bases of the trapezoids are the sides that are parallel to each other. So the altitude of a trapezoid is a segment that is perpendicular to both bases. So it meets both bases at 90 degrees. That altitude is known as the height of the trapezoid. So that brings us to our trapezoid area formula. Area of a trapezoid equals half the product of its altitude and the sum of the lengths of its bases. So area equals 1/2 times h multiplied by, in parentheses, base 1 plus base 2. So to do the area formula correctly, you need to add the bases, and then you can do 1/2 times the height times the sum of those bases. So make sure you add the bases first before doing any multiplying. So example 1 here, we have a trapezoid, QRST. We need to find the area. Our altitude, right here, QT, meets our two parallel sides at 90 degrees. So in that case, we would have 1/2 multiplied by 6 multiplied by the sum of the two bases, so 9 plus 5. So 14 multiplied by half of 6, which is 3, giving us an area of 42 square units. So again, add the bases, multiply by the height, multiply by 1/2. The parallelogram area formula. So if we're dealing with a parallelogram, it says the area of a parallelogram is the product, so multiplication again, of the length of one of its bases, because we know the bases in a parallelogram are congruent, to the altitude of that base. So the altitude is also our height, meaning it meets one of the bases at 90 degrees. So simply put, the area formula for a parallelogram is base times height. And again, base and height meet at 90 degrees or our perpendicular. So looking at our parallelogram over here, parallelogram TRIG, to find the area, we'd have to find our base, which is 15, and the height that meets it at 90 degrees is 6. So the area is simply base times height, 15 times 6, which is 90 square units. Then we get into our final theorem, but first we're going to look at the proof for that theorem. So don't worry about having to create this proof from scratch. This proof is what will lead us into our final formula right here. So we're dealing with a quadrilateral, ABCD, and what we know about this quadrilateral is that segment AC is perpendicular to BD. So what we can say are the diagonals of this quadrilateral are perpendicular. They want us to then prove that the area of the whole quadrilateral is half the measurement of BD times AC. So it's half of the two diagonals multiplied together. So let's look at this proof. First off, AC perpendicular to BD was given info. Then the area of triangle ABC is 1/2 segment BE times AC. That comes from the triangle area formula. Area of triangle ADC then is 1/2 segment DE times AC. Again, justification is triangle area formula. So then we know that the area of ABCD is the area of triangle ABC plus the area of triangle ADC. That comes from the area additive property or area postulate. We can add the areas together to get the overall area. And then we get into step 5, which is simply taking the numbers, or not necessarily numbers, but the equations from 2 and 3 and substituting them in for the words in step 4. So area of ABCD is equal to 1/2 BEAC plus 1/2 DEAC. And that was just substitution. Then if we use the distributive property, we end up with the area of that whole quadrilateral ABCD being 1/2 the distance BD times AC, and that was from the distributive property. Now, the reason that this whole thing matters is, like I said, that just built in to this final formula. And this formula is the perpendicular diagonals of a quadrilateral area formula. So if any quadrilateral has perpendicular diagonals, we can find its area using this formula. And it says that the formula is 1/2 the product of the diagonals. So it would be diagonal 1 multiplied by diagonal 2 multiplied by 1/2, or divided by 2. So if we're looking at a kite, which we know kites' diagonals are perpendicular, so to find the area of this kite, it's going to be half the measure of the product of the diagonals. So HJ times KG. So 1/2 KG times HJ. So 1/2 is 7 times 11. Gives us the area being 38.5 square units. So again, the main idea for this lesson is that these different area formulas that we're looking at, the 3 main ones, come from that idea of an area of a triangle being 1/2 base times height, and that idea of altitudes being segments that meet bases at 90 degrees.